Okay, today in 5.8 we have reached the last section of 5.8, and we're going to cut this section into two pieces because it's a little intense, and we're going to talk about special right triangles today. We've been talking about triangles a lot this year, and we're just going to talk about one specific type of triangles, 45, 45, 90 triangles today. And before we do that, I want to just go back and review how to do Pythagorean's theorem and how to put expressions into simplified radical form. So if I give you a question like number 2, for example, and we want to find out what the hypotenuse is, you're going to do Pythagorean's theorem. So that's 1 leg squared plus another leg squared equals the hypotenuse squared. And 2 squared is 4, and 3 squared is 9. Oh, I don't like this one. Okay, equals x squared, and 4 plus 9 is radical 13. So that's how long the hypotenuse is. Now, if you wanted to simplify, can you break 13 down into anything? No, 13 is a prime number. So your answer is just going to be radical 13. You can't simplify it anymore. How about let's try number 1. 5 squared plus 10 squared equals x squared. So 5 squared is 25. 10 squared is 100 equals x squared. Okay, and so we have 125, radical 125. And if you pop that into your calculator, you're going to get a decimal. So you know that you can put it into simplified radical form. We can try to break this down. So 125, if you divide it by 5, let's see, what do we get? Oops. 125 divided by 5. 25. Okay, cool. And then we know 5 is a prime number, so we leave it alone. 25 we can break down into 5 and 5, and then we have all 3 prime numbers. We don't look at anything else, just the prime numbers. Here's a pair of 5s. They go out together. Here's the loner, stays in and does his math homework. Your simplified radical form is 5 radical 5, and you can always pop it into your calculator. It should have the same decimal as radical 125. So we're going to be simplifying radicals some more. Also, it's really important that you remember that we do not have radicals in the denominator. To get a radical out of the denominator, what you do is you multiply both the top and the bottom of the fraction by whatever's on the denominator. So by the radical that's on the denominator. So because what's radical 3 times radical 3? Well, radical 3 times radical 3. 3 times 3 is 9. And what's the square root of 9? 3. So something special happens when you multiply a radical by itself. It gets rid of the radical, and you're left with what's underneath the radical. So this denominator is now going to be 3. Now we don't have a radical on the bottom. Everything's fine. Now on the top, we cannot combine a 12 and a 3. We can't say 12 times 3 is 36 because there's no radical with the 12. So we just push them together like this. And most people are going to leave it here. Well, let's look at the whole numbers. We can't combine whole numbers and radicals, but we still can simplify the whole numbers, because 12 divided by 3 is 4. So 4 radical 3 is really your correct answer. Okay, number 4. Number 4, people are probably saying, well, wait, there's no radical on the bottom. This should be fine. Well, radical 20. Let's see if we can simplify radical 20. So 20 could be 2 and 10. 10 is 2 and 5. Just look at the prime numbers. And we have a pair of 2's that go out together as 1. And we have 1 loner that stays in. So this is radical 20 simplified. And now, again, look at the whole numbers. What's 2 divided by 2? Well, that's 1. So your final answer is radical 5. So this still can be simplified. What I want you to remember is we still need to simplify radicals today. And we cannot have radicals on the bottom. It's a big no-no. Okay, so let's talk about why 45, 45, 90 triangles are so special. They're so special because 45, 45, 90 triangles, they have the same angles, 45 and 45. So if their angles are congruent, what does that mean about their opposite sides? Well, that means that their opposite sides are going to be congruent to each other because it's an isosceles right triangle. So another name for 45, 45, 90 is isosceles right triangle. These are the same thing. Okay, so let's say, for example, that I told you this side was x and this side was x. And just given that this side was x and this side was x, I want you to find the length of the hypotenuse. So we'll call that C. All right, so we know we have to square the legs, and that's going to be whatever the hypotenuse is. Okay, I'm gonna put a blank right there. I'm not even gonna put a C. I don't want to confuse you with another variable. Okay, so x squared plus x squared. Well, 1x squared plus 1x squared is 2x squared equals whatever the hypotenuse is. Okay, and then squared, excuse me. So then we have to square root it, correct? So to find out what the hypotenuse is, we have to square root this side. So we have a radical 2x squared that we need to simplify. And whatever that is, that's going to be our hypotenuse. So, okay, well, we can break this up into a radical 2 times a radical x squared. Now, radical 2 we cannot simplify. That's a prime number. X squared, though, what's the square root of an x squared? Well, these cancel each other out, and we have an x all by itself. So x radical 2 will be the hypotenuse if this side is x and this side is x. So the reason why that might be confusing to you guys at first, this is a shortcut. I want you to remember that you can always do Pythagorean theorem. Always do Pythagorean theorem if you do not understand the shortcut. But if I tell you, for example, now that the side of the right triangle is 8, well, if I tell you that this side is 8, what do you think the other leg's going to be? Oh my gosh, that's going to be 8 as well. And then what do you think the hypotenuse is going to be? Well, that's just, we already know x is 8. So the hypotenuse is just going to be 8 radical 2. In a 45, 45, 90, there's always going to be a radical somewhere, most of the time. I'll tell you why there might be some exceptions, but there should be a radical somewhere. Most of the time, it's going to be on the hypotenuse. Most of the time. Okay. So let me give you some examples. Again, oh my gosh, we already did this one. Let's cross out the 8 and let's say it's a 10. Sure, why not? Okay, so let's say this side is 10 and we know this side is 10. We want to figure out what x is. Again, you can always do Pythagorean theorem. There is nothing wrong with doing Pythagorean theorem. 10 squared is 100. Plus 100 equals x squared. We have now 200 equals x squared, and then we have to do radical. And so now what you have to do is you have to simplify radical 200, and you know that's 2 times 100, and 100 is 10 times 10. There's a pair, they go out together. There's the loner, stays in. Now, again, the shortcut, remember, this is how I always draw it. It's x radical 2. So for 45, 45, 90 triangles. So 10, 10, 10 radical 2. You don't even have to do Pythagorean theorem. If you know what the side is, all you have to do is multiply the hypotenuse by radical 2. So if you understand the shortcut, that's fine. What happens if this leg has a radical in it already? Again, the shortcut for a 45, 45, 90 triangle is to take this side and multiply it by radical 2, and that will always equal the hypotenuse. So the side length is 10 radical 2. And if you multiply that by radical 2, that should equal the hypotenuse. Side length multiplied by radical 2 equals the hypotenuse. So what is a radical 2 times a radical 2? Well, that's radical 4, and the square root of 4 is 2. So what is 10 times 2? That's 20. So the hypotenuse is 20. Again, like I said at the beginning, there should be a radical somewhere for the most part in 45, 45, 90 triangles. Okay, so in this case, it's not in the hypotenuse, but it is in the side legs. All right? Okay, so that's one type of question you'll see. The other type of question is, what happens if I give you the hypotenuse? Well, okay, let's think about it. If we take this side and multiply it by radical 2, that should be the hypotenuse. That's the shortcut. Now, if I give you the hypotenuse, well, and I want to figure out what the side is, well, the side is just going to be the hypotenuse divided by radical 2, right? If I wanted to get the side by itself, I would divide both sides by radical 2. So this is another shortcut. If you can remember these two formulas, if you can just remember this formula, you're going to remember the shortcut. However, you can still do Pythagorean theorem. So Pythagorean theorem, x squared plus x squared equals 5 squared. 1x squared plus 1x squared is 2x squared equals 25. And then you divide both by 2. Keep it as a fraction. Now you have x squared equals 25 over 2, and you have to square root both sides. Okay, so now you have the radical 25 over radical 2. Radical 25 is 5. We have a radical on the bottom. What do? That we have to multiply both the top and the bottom by radical 2. This comes out to be a nice whole number. This, you can't do anything, you just smush it together. So 5 radical 2 should be your answer if you do Pythagorean theorem correctly. If you want to do the shortcut, I'm going to pause it right here.